now or still in the bus? Can you hear me? Hello? Hello, everyone. Can you hear me? Okay. Are you all in your room or still in the bus? Bus number 2? Already in your room? Because we're going to do the exercise. Because yesterday, maybe some of you at the back cannot see clearly lah. Today we do some more exercise. Okay. We'll show you step by step here, right? Okay, now sometimes in the in the question, the streams are not given. The details on hot stream and cold streams are not given. For example, if you are given with this flow sheet, okay, you need to what's the question now? You need to design a heat exchanger network for maximum energy recovery that features the minimum number of unit using delta T mean equal 20 degrees C, right? So what is the first step? This is, you have this process with 2 reactors and 1 separation process, okay? Now, the streams are given, the temperature and the heat duty also given. Now, first of all, you need to extract the information, right? Can you all see the flow sheet here? So now let's extract the information given. This stream. So you have, okay, you have stream. Okay. The first stream is feed 1. What is the supply temperature? TS is 20. Sorry, put it here. So yang no need to put unit. Okay, so what is the target temperature? And then what is the heat duty? And then you also need to calculate the CP value, right? So the first stream is, okay, now what's the type, stream type? Okay, the supply temperature is 20. Now target temperature is 180. So is this a hot or cold stream? This is a what? Cold stream that requires heating. This is your heater, right? So this is a cold stream. Cold stream that require heating. And the delta H value is 32. This is in megawatt lah. And then now, can you calculate what is the CP value? Using this equation, delta H equal to CP delta T, where CP is the specific heat capacity flow rate. Flow rate times CP value is your CP. So to get CP, you divide what? Delta H with delta T. So can you calculate? 32 divided by 180 minus 20, you get berapa? 0.2. Is it? Mana calculator? Thirty-two divide by 160.
Sorry, doctor.
Yes?
Did you write something on screen? Is it? Because we can't
Oh,
see.
oh, you cannot see?
Yeah, yeah.
Okay, thank you for the information. Thank you. Wait, I set, reset the screen now. I think I need to share the screen. Cannot share the tab. Um, where is tadi ni? Hilang lah. Okay, can you see my screen? I need to rewrite. Okay, now.
Yes, doctor.
Okay, boleh nampak tak my
Yes,
pen?
yes.
The red
Doctor.
pen.
Thank you.
Okay, now start with, okay, thank you. Start with this feed. So now you extract the information first. You have what type of stream, or streams, and then type of stream, hot or cold, and then the supply, and then the target, delta H, and CP. Now, this stream from 20 to 180. So this is a cold stream because it requires heating. So stream feed 1. Feed 1. And delta H is 32 in megawatt. And then how to calculate CP? Delta H equal to CP times delta T. Now, how to calculate the CP here? Delta H is 180, right? Divided by 180 minus 20. You get the CP value. So your CP value is 0.2. And then next, you have this stream from 140 to 200, 140 to 230, right? And then delta H is given as 27. Now, can you tell me what is
The delta
yes?
H is 32, isn't it?
No, feed number 2.
No, for feed number 1.
Feed number 1,
To get the CP, isn't it need to
uh,
use the
uh,
32 divided by?
32 divided by 180 minus 20. And then similarly for here, this is a cold stream, right? So to get CP value is 27 divided by 230 minus 100, 140. You get 0.3. And then what's next? You have this stream from 200 to 80. So this is what? This is product 2, and then product 2, because it come from reactor 2 lah. So this is the product from reactor 2. So this is a hot stream because it requires cooling, right? From high temperature to low temperature. So it requires cooling, meaning that this is hot stream lah, right? And then what is the value of delta H? Negative 30. Now how to calculate CP? Negative 30 divided by 80 minus 200. So you get 0.15. And then what else? You have this stream, product from reactor 1. From the temperature, supply temperature is 250 to 40. So meaning that this is a hot stream because it is from high temperature and then requires cooling to achieve 40. So this is hot stream. Now, what is the value of delta H? Negative 31.5. So now how to calculate CP? Negative 31.5 divided by 40 minus 250. So you get the CP value equal to 0.25. So is that clear? So this is how we extract the data from this flow sheet. Okay, can we proceed? Okay, next. In order to design a heat exchanger, what is the information that you need in order to design the heat exchanger network? You need to know what? T hot pinch. What is the T hot pinch, T cold pinch? And then what is the value of QH min and QC min? So you need these data, right? Now, how to get this data? How? You need to do what? You need to construct either composite curve or you need to do the problem table algorithm, right? In order for you to get the minimum value of heating utility, hot utility and cool utility, as well as the pinch temperature, right? So you have this. What's the question just now? Using T min. Now you need to use T min equal to 20. Okay, now what is the first step to construct the problem table algorithm? You need to what? You need to have the shifted temperature, Ts star and Tt star, right? Oh no, terpadam ke? Okay, tak apa. Next kita, I tulis balik yang tadi kita extract the information tu. So we have feed 1, feed 2, product 1, and product 2. And then the TS is 20, TT is 180, and then 140, 230, 250, 40, 280. Okay, now you need to have TS star, the shifted temperature, and TT. Now, how to get the shifted temperature? Remember, you for hot stream, you need to minus delta T min divide by 2, and for cold stream, you need to plus delta T min over 2, right? So just now, delta T min, you need to use delta T min equal to 20. So 20 divided by 2, you get 10 lah. So for hot stream, this is the first two is hot stream. Sorry, the first two is cold stream. This is cold stream require heating. So cold stream, hot stream, and hot stream. Right. Okay, so for hot stream, you need to minus 10 lah. So this one becomes 240, and this become 30. This become 190, and this become 70. And then for cold stream, you need to plus 10. So 20 plus 10 is 30. This one becomes 190. This become 150, and this become 240. Right. Now, okay, clear? Okay, once we have the shifted temperature, then we can draw the intervals. Now you using this shifted temperature, you start doing the interval from starting with 240 and then 190, then 150. You arrange in descending order, okay? And then 70 and 30. And then you draw the stream. The cold stream is the first one is 30 to 190. And then what is the CP value? The CP value that we calculate just now is 0.2, right? And then what is the second cold stream? From 150 to 240, and this has a CP value of 0.3, right? And hot stream 1 is from 240 to 30, 240 to 30 with CP value of 0.15, right? And then next is hot stream number 2 from 190 to 70 with CP value of 0.25, right? Now you need to calculate the interval difference. So delta T here is 240 minus 190 equal to 50. And then 190 minus this become 40. And this 80. And this one become 40. 70 minus 30 is 40. Next, you need to calculate what? You need to calculate the summation. Okay, the summation of CP cold minus the summation of CP hot for each interval. Right. So for this interval, okay, CPC is 0.3, CP hot 0.3 minus 0.115. I'm looking at this interval. So you have only two lah. One cold stream with CP value of 0.3 and then one hot stream with CP of 0.15. So CP cold minus CP hot 0.3 minus 0.15 become 0.15, and then this interval you have what? All streams. So CP cold 0.2 plus 0.3 minus 0.15 minus 0.25, you get 0.1. And then similarly for this interval, CP cold, the summation of CP cold 0.2 minus summation of CP hot 0.2 minus 0.15 minus 0.25, you get negative 0.2. And then this interval 0.3 minus 0.115, bukan, 0.2 minus 0.15 is 0.05. Now you can calculate the value of delta H by multiplying these two columns. So 50 times 0.15, you get 7.5. This one multiplied by this, you get 4. 80 times negative 0.2, you get negative 16. And then 40 times 0.05, you get 2. Okay, so negative indicate the surplus, the heat. Surplus mean that you have additional heat to be shared. And then positive value indicate the heat deficit. Okay, right? Now, what's next? You need to what? You need to construct a heat cascade because you want to cascade heat from top to down the interval, right? Uh, Up to here, any question? Right. So, what is the first step in doing the cascade table? Similarly, you start with this interval, right? So start with the same interval just now, to 240, 190, 150, 70, and 30, right? Okay, and then uh, rewrite the delta H that you have calculated just now. For the first interval is 7.5. So delta H here is 7.5. You're going to cascade the heat down, okay, from hot utilities because you want to find what is the minimum hot utility and minimum cold utility required. And then going down to this interval, your H is delta H equal to 4. And then going down, delta H, this is from the calculated value just now, negative 16. Yang kat sini, this column. No, this column. Okay. And then next, delta H equal to 2. And then going to the cold utility. Now, assuming there is no hot utility, you're going to cascade the heat from top to the down of interval, right? So you're going to subtract lah, negative 7.5, you get negative 7.5, and then this one minus 4, you get minus 11.5. This is megawatt, and then going down, cascading the heat. This one minus, so plus minus 16, so plus you get 4.5 megawatt, negative 11.5 minus 16, you get plus lah, right? Then this one minus 2, you get 2.5. This is megawatt and this is megawatt. Right now, you have this negative value of heat flow, so this is not feasible. Now you need to add, now you take the highest negative value as your hot utility here on the second cascade table. So you're going to start with the maximum negative value. So you put your hot utility as 11.5 megawatt. Now you're going to cascading the heat of 11.5, and then this one, because at this interval there is a heat deficit of 7.5, so minus becomes 11.5 minus 7.5 become 4, right? 4 megawatt, and then this one minus 4, you get 0 megawatt, and then plus 16, you get 16 megawatt. Next, this one minus 2, you get 14 megawatt. So now, can you tell me what is your QH min and QC min? QH min is is what this actually from the top here is hot utility. So the top here is your hot utility. So your QH min is 11.5 megawatt, and then this is your coal utility. So 14 is your coal utility requirement. And then can you tell me what is your T pinch? Pinch temperature is when there is no heat transfer or zero heat transfer. So T pinch is equal to 150. But for hot stream, the pinch temperature is 150 tadi, because this is T interval, right? T interval. So the actual one is for hot stream, you need to plus 10. Because just now you will subtract 10 kan. So plus 10, you become 160. And the pinch temperature for cold stream is 150 minus 140. Minus 10 become 140. Now you have your QH min, QC min, and the pinch temperature for hot and cold stream. Now you can start design your heat exchanger network. Right. So now up to here, any question? Any question? Up to here. Right. So once you know the T hot pinch, T cold pinch, Q H and QC min, now you can start constructing or designing your heat exchanger because you know your pinch temperature is 160 and 140 for hot and cold stream. Now we start with the area above the pinch. We know that above the pinch, number of hot stream must be less or equal to number of cold stream, and then the CPH value must be lower or equal to CPC value, right? So now first and foremost, you need to draw the stream first. So you know that the hot pinch is 160, and then the cold pinch is 140 and 140. What is the meaning of ni? For those yang tak tahu, what is above the pinch? Above the pinch, yang the area, if you can recall your composite curve kan, TH kan, this is your composite curve, right? So let's say this is your T pinch, right? So the area above the pinch is here, meaning that with high temperature, and then the area below the pinch is with low temperature lah. So above the pinch is the area above temperature, above the pinch temperature lah. So looking at this stream, the first stream, now you start with hot stream first. So from 250 to 40. 250 to 40. So start with 250 and then until 40 lah. So because your pinch temperature is 160, so we stop here lah. Meaning that this is the area above the pinch at high temperature. And then next hot stream is 200 to 80. 200 to 80. That one is below the pinch. So 200. And then next cold stream is this one from 20 to 180. 180 from 20. But then now we we going to design for area above the pinch, so no need to put 20 kat sini. Okay, this is 180 degrees C. Next is 140 to 230. 230. And then list down the CP value. CP value yang kita calculate tadi is okay. So for hot stream, mana CP value tadi? CP value is nah this one. Ni CP value. Sebab yang the one that I write just now dah already hilang dah. So okay, this CP value. So the first hot stream is 0.15, 0.25, 0.15, 0.25, and then 0.2 and 0.3. So write the CP value first, and then using the CP table, right? You know that above the pinch, CP hot must be less than CPC. So now rearrange the CP value in descending order. So you have 0.25 followed by 0.15 and then 0.3 and followed by 0.2. You need to arrange in the descending order first. And now looking at these rules, number of hot stream equal to 2 hot stream and 2 cold stream. So both are equivalent. So this rule is fulfilled. Now you can straight away check the CP rules. So this one is less than 0.3. This one is less than 0.2. So now you straight away can pair lah between 0.25 and 0.3. 0.25 and 0.3. This stream and this stream. And then 0.15 to 0.2. Right now, what we already paired, but then we don't know what is the delta H value. Okay, first you need to calculate for each stream. Okay, how to calculate delta H here? 240 minus 160 times CP 0.15 equal to 13.5. And then next, delta H for this stream is 200 minus 160 times 0.25, you get 10. And then this stream, 0.2 times 180 minus 140, you get 0.2. And then this one, 0.3 times 230 minus 140, you get, this is 8. 8 and 7. Bukan, 8 and 27. Betul ke? Two 30 minus 140 times 0.3. Betul lah, 27. The 13.5, 10, 8, and 27. Now, we're going to design in such a way that we have a minimum units of heat exchanger. So we need to choose the minimum delta H. This is equivalent to the maximum delta H that we can pair lah. Okay, can take the two lowest one. So 8. So this is 8. Now pair with this stream. So this is 8. The duty is 8. And then this one, this stream, 10. Pair with this is also 10. Right. So which one is already fulfill the this one already? This stream already fulfill the delta H requirement, and then this one also. Okay. And now you need to add the additional heat exchanger to fulfill the delta H requirement for this stream and this stream. Now this required 13.5. So 13.5 minus 8, you get 5.5, isn't it? Yes, 5.5. You need to pair with cold stream here. So this is 5.5. So 5.5 plus 8, plus 8, you get 13.5. So this stream also finish. Okay, you already fulfill uh, the duty, the cooling requirement. And then this is 5.5. So 5.5 plus 10, you get 15.5. Now 27 minus 5, 15.5, you get 11.5. So another 11.5, you need to add the what? The heater lah. This because this is cold stream requires heating. So this is 11.5 megawatt. 11.5 plus 5.5 plus 10, you get 27. And then, like I mentioned yesterday, make sure that for heat exchanger pairing, the heat is passed to the cold stream from high temperature to low temperature. Now, can you calculate the temperature here? It's 160. What is the temperature over here? How to calculate the temperature? Using delta H equal to CPdt just now. Delta H equal CP delta T. So delta H here is 8 megawatt. The CP value is 0.15, right? And delta T is T here minus 160. T1 minus 160. So your T1, T here is equal to, can you calculate? Apa? 8 divided by 1.15, okay? Plus 160, you get 213 here. Meaning that, at sini, you need to calculate what is the temperature here. Similarly, how are you going to calculate here? 10 equal to CP equal to 0.3, and then times T2 here, T2 minus 140. Your T2 equal, can you calculate? 10 divided by 0.3 plus 140, you get 173. So looking at this, okay, this heat exchanger. Okay, this heat exchanger. Okay, let's say you have this heat exchanger. Let's name it as heat exchanger 1. Okay, heat exchanger 1, right? You have your hot stream. Okay, hot stream, and then changing the heat with the cold stream. So hot stream here is from 250 degrees C to 213 degrees C. And then this heat exchanger is from temperature kat sini berapa pula tak kira. Kira dulu. Okay, 5.5 equivalent to 0.3 times T3 minus 173. So your value is 5.5 divided by 0.3 plus 173, you get 1 T3 here is 191.3, meaning that yang masuk kat sini is 173 degree C, yang keluar is 191.3. Okay, now you have to make sure that the difference between this temperature, the difference between this temperature must be greater than your delta T mean. So 250 minus 191 is greater than 10. So okay lah. And then 213 minus 173 is less than, is greater than delta T mean 20. So meaning that this is a feasible mesh. So you can put it here lah. If let's say the difference temperature is less than your delta T mean, no, so you cannot put the heat exchanger here. You need to do another pairing lah, right? So we solve for heat exchanger design above the pinch. Okay, if you check this value of heater, the heater duty, is it similar to the one that we calculate from problem table algorithm? Your QH mean. Your QH mean, yes. Your QH mean is 11.5 megawatt. Similar that we calculate here. So meaning that your design is true lah. And then now, finish with the area above the pinch. You proceed with the area below the pinch. Okay, so 160, 160, 160. This is a hot T hot pinch, and then 140 and 140. Now, what is the stream that is located below the pinch? So hot stream number 1 is from your T pinch to 40, and then number 2 from the pinch to 80. So 40 and then to 80 degrees C. And then the cold stream is from 20, and then the second one is 140. And then 140 above. So meaning that you only have this is for below the pinch. Okay, your number of hot stream must be greater than or equal to number of cold stream. Now your hot stream is, you have 2 hot stream and 1 cold stream, meaning that this rule is fulfilled. Now you can proceed with a second rule. CPH below the pinch must be greater or equal to CPC value. Okay, now write the CP value first. 0.15, 0.25, 0.15, and then 0.25, and then 0.2. Now you need to rearrange the CP value in descending order. So for hot, 0.25, and then followed by 0.15. For cold stream, 0.2. So looking at this, the first one already fulfilled the CP rule, so meaning that 0.25 greater than 0.2. So now you can pair 0.2 with 0.25 with 0.2. So you pair. Okay, now before just now I didn't mention about this. You need to start from the pinch area to away from the pinch, meaning that you cannot start here. Macam yang this one, you cannot start here. You need to start with the area near the pinch, and then going going away to the pinch, meaning that from above the pinch, from right to the left, and then for below the pinch you need to start from left to the right. Okay, so 0.25 pair with 0.2, and then don't forget to calculate the value of delta H. Okay, the value of delta H. So how to calculate? 0.5 times 160 minus 40. You get berapa? You get 18, and then 0.25 times 160 minus 80, you get 20 and then 24, right? Okay, so now this one, the minimum one is 20, right? This one is also 20. Okay, 20, and then this one is already fulfilled because already 20, and then for this stream, okay, because the duty is 24, so you need additional heat exchanger with heat duty of 4 lah, right? So you pair with this hot stream. Betul lah. Okay, you pair with this hot stream, so you have another 4. And then this is 4, right? Okay, so 20 plus 4 is 24. So the heating duty is, the cooling duty is fulfilled. Now, tinggal yang the first stream, the first hot stream. So now this one 4, you need additional 14. So you need to add what? You need to add, because this is a hot stream, you need to add a cooler with a duty of 13. Duty of 14 lah. 14 plus 4 equal to 18. So that is how you do the pairing lah. So look, by checking what is the value of QC min from the problem table algorithm. QC min is 14, meaning that your design is true lah, because it achieves the minimum target cold and hot utilities. And then once you have done, you need to combine the hot and cold stream in one page, and then you are done lah, right? Any question? That is quite simple lah, because you don't need any stream splitting, right? Any question? Okay, now looking at this question, you have this one you can expect there is a stream splitting lah, because hot and cold stream pun hot stream is greater than cold stream. Macam yang the first question, you have 2 hot stream and 2 cold stream, right? But for this one, okay, you need to design a heat exchanger network for a maximum energy recovery, given that so you are given with the value of QH min, QC min, and pinch temperature. But if you are not given with this data, you need to start calculate this value using problem table algorithm or using composite curve as well. Okay. You want me to continue on this, because it's 6:30 already. If you want me to continue, then I will show you lah. You want me to continue or not? Hello, anybody's home?
Macam ada soalan kat Gmeet tu.
Apa dia?
Ada soalan dalam Gmeet text box tu.
Ada soalan Gmeet text box. Sekejap. Hang pula dah. Right, wait. Can explain the difference of temperature much larger than Okay, expect difference of temperature must larger than delta T min. Oh, yang tadi itulah yang rasanya dah terpadam dah ni. Dah terpadam dah. So what's the, macam mana you want me to explain on your delta T, tak boleh tulis pula. Okay, just now we have the heat exchanger pairing, right? Pairing between hot and cold stream. Okay, if both stream or only have one heat exchanger, then it's okay. You can just looking at the supply and target temperature. But if this stream, for example, okay, this, for example, you have another heat exchanger is paired with this stream. So you need to calculate the temperature here. Okay, for example, this is pinch temperature of 160, 160, and then this is 140, right? So you know that, okay, this is your heat, okay, this is your heat, let's name it first. This is heat exchanger 1. This is heat exchanger 2. Right, if you have your stream pair with more than one heat exchanger, then you need to find the temperature in between the two heat exchanger. What is the, for example here, at this stream, you know that the supply temperature is 140, right? And then what is the apa? The exit temperature of this heat exchanger? You need to calculate based from delta H equal to Cp delta T, right? So you need to calculate this temperature. If this temperature, for example, equal to 155. Okay, now you know that, for example, kat sini 200. Okay, 200, okay, now focus on heat exchanger number 1. So you have your heat exchanger. You know that in heat exchanger, the heat is passed from hot stream to cold stream, right? This is hot stream, this is cold stream. So you know that your hot stream is, the supply temperature is 200, and then the target, the exit temperature is 160. And then at this stream, okay, looking at the pairing of heat exchanger 1, you know that, for example here, your T entering heat exchanger is 155. Exiting, for example, 180. Now, you need to calculate the difference between these two temperature, between hot and cold. So, what is the delta T here? 200 minus 180, which is equal to 20. And then this one, 160 minus 155. Delta T here is 5 lah. Meaning that because delta T min just now is 20, because hot pinch, T hot pinch minus T cold pinch is 20 degree, right? So meaning that delta T5 here is lower than delta T min, which is not feasible. So you cannot pair. You need to remove this pairing because it is not feasible, because the delta T here, the value of delta T here is lower than the value of delta T min, because if you refer to the pinch principle yang tiga pinch principle tu, the first principle is your delta T cannot be less than the delta T min. So that's why that's the explanation on the pairing just now. You cannot the difference temperature cannot be less than delta T min. So macam ni tak boleh lah, infeasible. Yang this one okay, tapi this side tak boleh. So you cannot do the pairing. But if let's say you calculate using this, you calculate for example T here is 100. Katalah sini bukan 150 lah. So maybe this 120 and then T here is 140. So okay lah. 160 minus 140 you get 20. So it satisfy the pinch principle. The delta T value is less than or cannot be less than or is greater than delta T min. The greater or equal. Kalau 20 okay lah. Your delta T must be greater or equal to delta T min. So the minimum one is 20. Okay, kalau 20 is acceptable. Okay, that is the explanation on yang you tanya tadi tu. Siapa tanya? Ui. Yesterday punya exercise yang I show at the whiteboard tu, because that's the case lah where your not this case, but then the case yesterday is that hot stream, the temperature of hot stream is lower than the temperature of cold stream, which is also not feasible lah, right? Faham tak? Okay. You want me to this exercise, another exercise involve stream splitting lah. When it involves stream splitting, the solution is quite complex because you need to do try and error lah. Okay. So I swear only stream splitting will be come out in your final exam lah. Okay. And okay, because I mentioned yesterday we have two questions, but both are in the second part B. You can choose only one. So how to choose what's the tips on how to choose the simple problem lah, because you want to save time, right? So my tip is you choose the question with less number of stream. You take a look at two. Maybe you choose the question that have lower number of stream, so that it's easier for you to do the hand design, heat exchanger network design lah. Okay. And make sure all of you not only able to do, but I mean you need to be expert lah, because you want to save time, right? Because you have 5 questions, so basically you need about 30 minutes per question, 30 or to 35 minutes per question. So you need to do it in you need to do it very quickly lah. So you need to practice. Okay, so like I mentioned just now, I cakap before this, you need to make sure that you able. But today I'm saying this, you not just to be able, but you need to be expert. Meaning so that you can save more time. Okay. So for the second question, maybe I can upload the solution lah for you. You can try first, but I will upload the answer later. Okay. Any question? I hope all of you understand on how to design the heat exchanger network. Okay. Any question? Any other question?
Hello, doctor.
Yeah.
Is it the two questions involve the splitting of stream in the final, or only
Yes,
one
obvious.
question?
Two question involve stream splitting, but then those, what's the difference is maybe you have a different pattern of question. Maybe this question involve data extraction, for example. And then another question doesn't involve any data extraction, but then with many number of stream, for example. Okay, so the tips is, for me, better to choose uh, the question with a low number of stream so that you have more time to finish. Even though you need to extract the data, but that's the tips lah. Okay. Dah bocor dah soalan ni. Aduh. Any other question?
Thank you, Doctor.
Okay, welcome. Share the attendance. Attendance. Right, so this is the attendance for today. So that's all. That's it. We finish heat integration, and then we're going to continue. Maybe we need another 1 week to continue on another chapter lah. Maybe I need another 1 week after your mid-sem break. Okay. And probably we're going to have your quiz number 2 lah. Right after your mid-sem break. Okay. Right, if there's no more question, then we can dismiss our class. Thanks for your Thanks for your attendance today, and thank you.